This demonstration addresses orchestration operation to enable 5G-based connectivity for coverage extension as a service. Network function virtualization is one of the core technologies related to the Beyond 5G ecosystem, and in turn should be handled in the DEDICAT6G project, especially in coverage extension. The specific element in the DEDICAT6G is to interact with the external NFV system, is the orchestration engine. Our component will be responsible for being the main link between the decision-making functional components and the external NFV orchestration to properly instantiate the ad hoc network slices. The orchestration engine aims to help the decision-making functional group to implement its recommendation in the external Beyond 5G system. To this end, we propose the following design. The engine manager coordinates all the internal procedures. The descriptor creator automatically creates the descriptor based on the recommendation received. The OSM client is able to create connection to OSM to command it. A gRPC base exports the functionality of the orchestrator engine to be requested externally. And finally, we consider a cache database to store some internal management data. This experiment was carried out in the telecom testbed in Atos premises. First, the orchestration engine and the functional component have been written in Python and implemented in a microservice-based approach, each in separate Docker containers. Container uses gRPC channels by leveraging a Docker bridge. In addition, the orchestration engine can command OSM using its OSM REST interface. Also, the edge nodes are modeled in two separate open stacks, one represented as markup and the other as ROM. And finally, the network slice considers two network services, one to be instantiated at each node, with 2 and 1 BNF respectively. Here in this video, we can see a terminal showing the 4 containers running in a Docker environment. Next, we can see 5 terminals, 2 at the top run in the orchestration engine container, and the 3 at the bottom are IDDM, CEDM, and NODM terminals. To start the workflow, first we launch the gRPC server in the orchestration engine. Then the other containers can send their outputs to the orchestration engine using gRPC channel. As can be seen in the terminal on the top left, the messages are received on the server and follow the same structure as defined in Work Package 2. Once the messages have been received by the server, for the case of this demo, we manually execute the operation related to the engine manager to first create the corresponding descriptor to define the network slice including the information just received, and onboard it in OSM for its later use, as we can appreciate in the message in OSM client logs in the terminal on the top right. Then the permissioning of the network slice in the NFV system is requested. To check its correct instantiation, firstly, in the OSM dashboard, we can see how the descriptors are available in OSM, both the network slice template and the network services, and also the BNF descriptors. Also, in the OSM dashboard, it can be checked that the network slice instance is up and running with its associated network services and BNF instances correctly instantiated. To test the end-to-end connectivity in this multi-site network slice, we can directly access the BNF instances in both OpenStack. We can see how the 3 BNFs, 2 in the emulated OpenStack and 1 BNF in the drone, are instantiated and belong to the same backbone. Next, we show in the terminal how virtual machines associated to the BNFs placed in different nodes can reach each other just by pinging between them, thus demonstrating the correct provisioning of the network slices commanded by the orchestration engine that can be suitable to a real coverage station as a service request. To conclude, we have shown some functionality of the orchestration engine aimed at instantiating commanded network services. This work follows a design based on cloud-native microservices, suitable for deployment in both cloud and edge domain. In addition, we have implemented the output data model provided by the functional components IDDM, CEDM, and NODM defined in deliverable 2.4 in separate containers. Finally, our roadmap includes extending the functionality of the orchestration engine to support Kubernetes in the deployment of DEDICAT agents in vertical apps.